Okay, welcome to Nested Loops session 3. We're going to wrap up the last few pages of chapter 2. I'll do that, and then Andrew will pick up 3. So it's been 2 weeks. We developed a gear class that we have been gradually, due to single responsibility principle, extracting out a wheel class. So I believe the part I'm going over, we went over before, but I thought we'd recap. So if we look at the code in the left of my window there, we can see, okay, we have a gear class. It has header readers, chainring, cog, wheel. We have initializer where we pass those values in. You can see at line 6 there, we have a wheel, new, rim, tire. And we extracted this object out of assorted methods from before. We have a ratio, cog divided by, chainring divided by cog. We have gear inches. You can see we use the wheel diameter down there. And then we made a nested class inside of gear here, wheel, via the Ruby convenience structure of doing a struct new and then putting a method with in the do block diameter. So wheel knows how to get its own diameter. And previously, we had been like calculating that, like gear was doing all the manipulation. And so for object-oriented programming, we expect the wheel to know how to get its own diameter, and it's always better to send messages than do stuff yourself. So for this decision here, if we look at the second paragraph on the right here, Sandy talks about, oh, right here we suggest we only expect it to exist in this context. And, you know, she suggests here, if you look outside, you see that's not right in real world. But per what our discussions last session, which unfortunately were not recorded, context and life and exposure of classes all really depend on like the lifestyle or the life cycle. If this is a throwaway script, no real need to make a standalone class. If you anticipate longevity or reuse, then you kind of pull it out. And she mentions here, you know, right now enough information supports making an independent class. Every domain is not this clear cut. If this is a throwaway script that you're writing, you know, 20 minutes to do something in 10 minutes, you don't really need to do that one. But in general, we don't want too many responsibilities. That makes them muddled from there. So with all this discussion here, we're now ready to see the real wheel class here. So, and the scenario she sets up is you show your calculator to your friend, and your friend has new requirements like, oh, now I want to add bicycle wheel circumference. And with this new requirement, you realize, okay, now we know enough to extract wheel and do what it does. She talks about, well, you know, circumference is pi times diameter, and you already calculate diameter, so it's easy to add a method for circumference. So let's pull it out in its own class. So now if we look at the final method now, we have here, it has its adder reader stuff here, it has the same initializers before, same ratio, here inches. Oops, sorry about that. And on the next page, we have the wheel class. Now we can see at this point on line 18, the wheel class is pulled out by itself. We no longer use a struct, and the discussion we had at the end of last session was neither Diego or I tend to use struct for anything that we think will last, because it's rare that it's only ever a struct, and that fits in well with object-oriented programming, where, yeah, I mean, that goes back to C, where I have structs, and then I write functions that deal with these structs. But no, OO is, you know, about behavior and data together. So I almost never do a struct unless it's a throwaway. I think Diego came to the same conclusion. So he pulls his own class, and you only save a couple of lines. Class wheel, rim and tire added there, the initializer. You can put the rim, tire, when you create it, it knows how to do diameter, knows how to do circumference, and then some example uses here, wheel.new, wheel.circumference. You can pass that into gear, and then you can figure out this ratio from there. So at this point, both classes have a single responsibility. Code's not perfect, but while in some ways it gets a higher standard, and again, there's always the balance of how clean you need to make your code And really, it's the context from there. Sandy says it's good enough. And ultimately, the summary here is single responsibility just makes for cleaner code, maintenance, and whatnot. So that kind of concludes chapter 2. If you have any questions, feel free to unmute and talk, because in my mind, the discussion is always the best part of these things. So questions, comments?
I think there's another interesting way to use the struct syntax, which is like this example here, line 18 could be class wheel, and then inherit struct. And then you could drop the lines below. I know that's not traditionally used like that, but you can actually inherit from a struct in the same line, especially if you don't like the wheel equals syntax.
Yeah. You could do that too.
So yeah, just I've never actually seen it used that way, but I did test and it works.
Yeah, no, I've actually, I can't remember which. I want to say the pickaxe book probably showed that. Is something that's the way to do it. It's something odd about that. I just don't like it. And that's more of a personal. Yeah, we could do that, but why? Because you basically save what in this class 5 lines.
Yeah, just 5 lines. I think it's better if it's going to be a standalone class, it's better this way.
Right, yeah, so it's like you save 5 lines, which again in your throwaway script is fine over time. I think in my mind, I like the uniform. I like classes that look the same. So I can say, oh, I got my editor, whatever's here, my initializer, and I'm looking at the same pattern. When it goes to a different pattern, you have to go, oh, wait a minute, what does this inherit from struct give me? Oh, it gives me a free initializer and a free editor accessors. And actually, in here, you're not allowed to set those. 19 is adder reader only, whereas struct makes those adder accessor. So it's actually slightly different. Okay, if there's no comments, we can roll it over to Andrew. I'll let him share his.
All right, thanks. So I went over chapter 3, managing dependencies, and so there's some great images later on that I want to focus in on, because that's really good. So it's split into 3 sections. The first section, identifying dependencies. The second section, dealing with the dependencies on a practical level. And the third section is, I think I'll need a little help with understanding the third section, but I'll wait until I get there. So section 1, understanding dependencies. So we're back to the gear object, and in this point, Sandy wants to point out that we from last section have now an external dependency, which is wheel, and the main point is that gear inches is now sending a message to an object named wheel, but also knows of an existence of an object called wheel. And here's the class wheel. Her point is that in this case, gear inches knows too much and is tied inextricably in this case to wheel. So anytime wheel changes, we'll go through that in a little bit. Gear inches breaks because it's tied directly to it. And so in the next section, subsection, recognizing dependencies, she has us focus in on 4 main things that this dependency would cause, what changes it would be that would cause it. So the first one is the name of the class. So if wheel became wheelie, the code breaks. Because now there's no more class named wheel. And in this case, in the next one, we're sending a message diameter to this object. So if it no longer accepts diameter, but now wants, I don't know, something like 2 pi radius is the new, method name, it won't respond to diameter. The next is that it's looking for arguments of rim and tire. And again, if those arguments change, and then followed by this last one, if the order of the arguments change, again, for all 4 cases, the script breaks, and we no longer have usable code, and we have to go in and we have to change it. So that brings us to coupling between objects, and this goes to this great image here, where on the left we see what is our gear and our dependencies, and one of them being wheel. And the great picture is over here on the right, where it shows that these dependencies, because, and she'll later use this term concrete, because this class is concrete, and oh, that's a bad term. Sorry. I'll forget what I just said. Because there's so many dependencies, and they're so tightly coupled, given by these finger-like, intrusions into gear. Anytime wheel changes, gear breaks, or let's say D or C or B or A. So it's very fragile, meaning that it's very susceptible to breaking whenever any of those change. Let's see, is there anything that I put down as notes? Not really. It's just giving a good idea of what it means to be coupled between those 2 objects, where it's almost as if you had little Siamese twins. And yeah, I don't want to go down that. Other dependencies. So in other dependencies, we go over something called message chaining. So it's similar to coupled between objects, but now you have, you're sending a message to an object that's, a dependency of, it's a dependency of the object that it's coupled to. So now you have, you have this image again, but now it's just like, it's nested. It's like a nested coupled between an object's behavior. So it becomes even more complicated trying to figure out what the error is. So in all, this is just a big warning. Dependencies look like they're benign. They look like they're not a problem, but in reality, if left as is, can become a very big headache later down the line. So now that we know what the symptoms are to having unchecked dependencies, the solutions is section 2, which is also known as writing loosely coupled code. So the question is, so if writing too many dependencies is bad, where do we want to be? And we want to be writing loosely coupled code. So the first of a few options that we have, the first one's called injecting dependencies. And this one is fairly simple to understand what's going on. Here, and again, we still have gear. Now we don't see the wheel class, but here we have wheel, and it's within gear inches, and gear inches, again, still knows everything about wheel. So the first thing to do is, well, we can init an object that responds to diameter. And so we do that later in this line of code. So now we remove the instance of class wheel with this instance variable wheel that we initialize. So now whenever we specify gear, we can send an object wheel as part of that initialization. And now we're not bound to the wheel class. Now we can be bound, we can use it for a disk, or a can, or anything that could have a diameter. And now that frees up wheel. Gear inches only knows that there's an object that has that can respond to the diameter message. I want to go over again what the problem is. So right above here, there was a good message to kind of just remember that when geared hard codes are referenced to wheel deep inside gear inches method, it is explicitly declaring that it is only willing to calculate gear inches for instances of wheel. Sorry. Gear refuses to collaborate with any other kind of object, even if that object has a diameter and uses gears. Again, so that's the problem with making explicit the wheel class within gear inches. It ties it, and you can't, and it can't be used for any other application, and it's very much almost like a waste of good work, not being able to use it anywhere else. So again, what we see here in this case, this solution is called dependency injection, where we take an object, again, wheel, and it's also an object that responds to diameter, which works perfectly with wheel class down here. So everything passes. So again, so in dependency injection, gear now only knows that an object responds to diameter, and then also it can collaborate with other objects that implement diameter. Great use. Oops. And then again, with what it should know and why it should know things. Just because gear needs to send diameter somewhere does not mean that gear should know about wheel. Okay, so that's the first solution. The second solution, isolate dependencies. And it's a fairly big topic. And so in this portion, it's when you can't remove dependencies for whatever reason. I'm not actually sure of the examples when I can't remove dependencies, but this is the case when we can't remove dependencies. So that, what do? We can do something called isolate the instance creation. So in this case, we can isolate where we instantiate wheel within gear, using a little bit the wheel object from above of injecting dependencies. We can instantiate a new wheel, or we can do something called a lazy operator, something that is highlighted by this or equals sign. So now wheel refers to, you know, a set get, but like a lazy set. So it checks to see whether wheel has been set already, and if it has, it won't make a new wheel. It'll just say, all right, get. And that's it. So now what has this done? So this these coding styles, you can't see it. Okay, yeah. So these coding styles reduce the number of dependencies in gear inches while publicly exposing gear's dependency on wheel. So we really didn't remove the wheel dependency in both cases. We can still see that we're calling something called wheel. But now gear inches in both cases is not seeing this wheel class. It's highlighting that there's a external dependency that we can get to later. So that's good if we go over it. We're down to the last minute and we're like, oh shoot, I have this external dependency, but I have to make this PR. Well, I'll just I'll isolate it, and this will catch my attention later down in the future when I have to refactor and I can deal with it in a better way. And so that leads us to, oops, did I go too far down? I think so. Isolating vulnerable external messages. So here, the important portion is what gear inches is what messages it's sending. So the first message that it's sending is a ratio to self, ratio and wheel to self. But the third message is sending diameter to wheel. So this is all about who's receiving those messages. And ideally, for gear inches, we want all messages sent to self. So we'll get to that in a little bit. The question is, why do we want that? And in this case, Sandy brings up this few lines of code where if we don't remove this message to this external dependency, we're embedding it. And so that becomes difficult. Now we no longer have this almost like a wrapper method, a very simple method up here. Now we have something much more involved, and it becomes tedious and difficult to actually find those problems. Whereas if it was isolated, it's a lot faster, and we can do a check against it. So what we do is something called encapsulating the external dependency. So now instead of sending a message to wheel, we now just call diameter a message that we send to self. And diameter now is just a wrapper method that does the actual calling to wheel. Again, now gear inches only sends messages to self, and we've more or less prepared and prepped everything just in case things would get more complex. Also, it no longer has any knowledge of any external dependencies. The question is, this seems kind of vague. When do we apply it? She says, although not every external method is a candidate for this preemptive isolation, it's worth examining your code and looking for the most vulnerable dependencies and starting there. So as long as the most vulnerable that you might see changing frequently or depending on something that's changing frequently, isolate those so that it not really future-proofs it, but in a sense, it's a lot easier to fix once something does change. So that's isolating dependencies. This one's, I'm not sure, but I think Ruby 2.5 may have done something where it does this default. I don't know. So that's all. But the next portion is called, this is what I mean, removing argument order dependencies, or sending arguments as a hash to an object. It's fairly straightforward. So as we see, gear has arguments, and they're in order. The 0 term, the first term, the second term. And so if you ever change the order, let's say cog expects an integer, chainring an integer, and wheel an object that responds to diameter. If I decide to put wheel in the 0s spot, it'll no longer work. The idea now is that if I have an object that I'm not too sure about its arguments and the order of the arguments, instead of passing an ordered argument list, I can send instead a hash. So here we see using hashes for initialization arguments. In the code now, instead of seeing a list of arguments, we have just an arguments hash that we then say that it responds to a chainring symbol, a cog, and a wheel symbol. We'll go through the advantages. The first one is that it removes the dependency on argument order. Now I can, however I want, I can define a hash that goes wheel, cog, chainring, or just wheel and cog and doesn't have chainring, which is great. Now, whenever my gear object adds more arguments, my code should still work, given that gear inches only looks for those 3 arguments, the ones that we're familiar with. The next advantage is that it adds verbosity. So now whenever a new developer, or if I, with tired eyes and, I recognize this code, but then, in 6 months or 8 months, I look back on it and I don't recognize, the indexes or what I'm doing. Hashes provide a very descriptive explanation of what's going on, which is nice. Third is that now it's more stable. That means that I can still initialize gear given different changes to gear, but previous code will still work. And that's really, really, really helpful. And the bonus is that now I have a little bit more documentation. And documentation is nice because it's nice not to have to write comments, because comments, get old quickly, since they don't actually actively help with the code, in a sense where I'm not changing comments every time I change code. With a hash now, every time that I do use a new element in the hash, it's self-documented. I know that if I have to add oil for whatever reason, so it's not so squeaky, I know that there's now a new oil element within this argument hash that defines the gear. So when do we use it? Well, it's a matter of how agile do we want to be, because really quickly doing an arguments list, that's the most agile. You pop those 3 out and then work with it. But if I know that it's going to become more and more involved, then a hash seems to work out the best, since it's always responsive and I can work with it very easily, and I'm not tied down to that order. So what's the middle of the road? Well, the middle of the road is to take a few fixed order arguments and then have it followed by an options hash. So that gives us, these first few arguments, they're always going to be there. The wheel's always going to be there, but oil and like helmet, I don't know. Those things could potentially, it's hard for me to come up with plausible arguments, but let's go on to the next section. Explicitly defined defaults. So now we have our argument hash.
Okay. I'm going to interject.
Yeah, interject.
It's the best time to interject. So the time that I find the hash argument saves you is when your stuff is in flux. Problem with like, oh, I got to add an entry. Oh, I got to remove one. I got to add 2 more. But then you have, especially with not having a statically defined. Which one? Ruby's dynamic, static languages. You're using Java, you change that one Java. Eclipse can tell you everywhere it's changed and change it for you. To some extent, RubyMine does it, but it's less good. But so when you're working with Ruby and your signature is changing a lot, especially as you're fleshing things out, that's a time where passing one thing helps you. Her comment on clarity, sometimes I have stuff that passes, arguments, but you forget what they are. You can do like, wheel.new, rim equal 10, comma, gear inches equal something. Now, even if you don't reuse those variables anywhere, it gives you the same readability that a hash does. And the reason I go towards that sometimes is, sometimes you want to be checked, hey, you need 2 arguments and you only pass 2, right?
Mhm.
If you put that in the signature, that's something that, you know, at least if you run special run code, will tell you, hey, I expected 2 arguments and only 1. Problem with the hash is you take a hash and then you have to explicitly write hash code. Oh, you didn't set this. And I know the next part talks about defaults. But sometimes there is no known default. I need you to give me 3 things. So you can't take a default, and passing a hash will always work. And the result of getting that, I mentioned it on the fetch, but you know, if you're not diligent and you just do args, you know, square brackets, whatever, and you didn't set it and you don't expect it to be nil, it will be nil. You get bitten in dynamic languages, in things that static languages don't give you this way. So and she does say, it depends on what's happening for you. But the times that it is the best is when you find your signature keeps changing. If you have that used in a lot of places, then you have to change it in a lot of places. And again, it would be being dynamic versus static. It's harder for even RubyMine to find things. It can generally do a pretty good job, but it's not perfect if it's not static. Not a static language. And the other thing is sometimes instead of a hash, you just pass an object. That's happened to me as I've been factoring it. Oh, I should pass more things. And then it's actually a named refactoring where you replace things, something like replace parameters with value object. It turns out you have parameters that are like rim and tire. Oh, that becomes wheel because those are parameters that are related to wheel. You pass in a wheel instead of rim and tire, and they have some other thing, 3 things that go with another class. So instead of the hash, sometimes you refactor these value objects, which being objects allow you to get a little bit of checking that the hash is done. The problem with hashes is flexible, but there's no checking if you don't write any checking yourself.
Okay, I have a question, but I'll save it until the end. I appreciate the point of view because she really doesn't go into, you know, what are some of the pitfalls.
Right, I think that's kind of the point. So this is the best part of study. When someone says, hey, I built this, and these are the things that go wrong, especially if it's not written about. So if you have a question related to this section, I think it's best to start now.
Oh, okay.
At the end, when we forgot what we were talking about.
Yeah, that's true. If I wanted to write that there are some elements of the hash that definitely needs to be you know, there to be initialized, can't I just do something where I, you know, raise an exception if, you know, let's say args wheel is nil?
You can, but you have to do that.
Mm-hmm.
And you know, and it's easy to not be diligent. So the least amount of require the programmer to remember everything, become together.
Okay.
Right? Don't count on your programmer to have, you know, photographic memory.
Can you speak a little louder?
A little louder. I have to put my headphones on. Is my microphone really that bad?
It can be just like you were too far away from the microphone, so it comes out a little muffled.
Sure. So I forgot what I was saying. Yeah, I mean, try to rely the least amount of the programmer's memory. That's kind of where static language IDEs really help you out. Is, you know, in Java with those gigantic APIs or .NET, you kind of need the IDE to tell you. But the beauty is it tells you and keeps you from making mistakes. So a certain amount of these categories, you realize, oh, well, Ruby's dynamic, and as good as RubyMine might be, it can't tell you all the things the other things can do. So you can always do your own checking. The problem is then you have to do your own checking.
Yeah, that makes sense.
Okay, so I think I'm good at this point.
All right. Since you mentioned it, I was gonna Andrew. Since you mentioned the keyword argument, there's something else actually. So you can do keyword arguments in Ruby 2.
Right.
In Ruby 2.1, you can require when you define the class, if you want to instantiate it, you want the keywords argument. And in 2.5, it's structs also allow for keyword argument and require of the keyword arguments. It's been added to structs as well. And the only thing I'm going to say about this is it's kind of me picking on the dependency on the arguments list, but it's actually happens quite often that you go back and forth and change the signature. And generally, I find myself, the moment I add a third argument to the class, I change everything to be an argument. Or maybe like 1 and 2 are like position based, and the third one is a catch-all arguments.
Yeah.
Because like when you start having like 4 or 5 arguments in a specific thing, it's like, no, this is just start smelling.
Yeah, yeah.
That's it.
So I think sometimes that defaults help in the case where sometimes things might be no. Could give you a silly answer. I don't know. I'm just ad-libbing there. But I'll try to segue into explicitly defining defaults. There's some really nifty ways of doing this. First one is using an OR operator. So in the case, let's say I don't have a chain ring, but I still want gear inches. Well, this OR operator allows me to set chain ring to 40. Same thing with cog. I think if wheel is nil, I think it'll just raise an error saying that I'm trying to send a diameter message to nil, and nil can't accept that. So pretty cool. The only caveat is that in the cases where arg contains a Boolean that defaults to true, I can't set it to false using the OR operator because it'll is that right? Let's see. For example, let me just read it out because I think it'll be easier to have her say it. In the case,
it's correct. Pretty much like if you do it with this syntax, it's always going to be true. Even if you press a false, which is the value that you want it say false or true. That always.
Yeah. So so it always comes out as true because this. The way she explains it is that the OR operator evaluates this, checks if it's false. If it is, makes the default the value on the right of the operator. So this is the question here of what happens if it's a Boolean and we want to set it to false. So if that's the case and we want to use Booleans, then a safer method to use, or I'm not sure if we can call it an operator, is fetch. Where now we can do, it's more or less the same thing, but now we've made it into a function where we said, if this exists, use it. If it doesn't, use that. I'm not sure if there's any other nuances to fetch. I think it's straightforward.
I want to comment on that. 1, it's not a function, it's a method.
Oh, sorry, yeah, method.
2, square brackets is also a method.
Yes, that's right.
Something that's different about Ruby than a lot of programming languages, where you have what looks like operators are still methods. That's it.
Okay. So you can do operators, you can do fetch, and then you can do something called isolating the defaults, where in this case we have a method defaults that returns a hash. Very similar to what we had above. If we can look at fetch, we still have the same values, default values for chain ring and cog, as we see here. But now what we do is we do a merge with the argument hash. And so any place that argument is nil, well, specifically if chain ring or cog or both are nil, they'll in this merge, we'll get a new hash that will have now instead 40 and 18 as the values for chain ring and cog, plus whether the wheel is a wheel class or a wheelie class or a disk class object. So those are our defaults. Setting our defaults when we have a hash. Our next chapter, next subsection of this section is isolating multi-parameter initialization, which is a mouthful. And let's see. This is when we actually can't control the methods that we're using. In this case, what we're doing instead is we're gonna make something known as factories. So to be quick about this, we have in this snippet of code something called gear wrapper, and now gear wrapper is going to be in our interface. And what this does is it allows us to define. I'm not sure how we can say this, but we can call a gear object that depends on an argument order. Sorry, here we can see our standard gear that we've been seeing all the time now has an argument list again. What we would like is we would like to use a hash, or at least Sandy would like us to use a hash again. So instead of dealing directly with gear, we now have an interface, or kind of like a class wrapper. I don't know if that's appropriate to say, but here we see a use of module that allows us to reference gear wrapper, and it's not really instantiated. We just use it, and it creates a gear for us. Where now we, instead of we don't say gear wrapper dot new, set that to an object and then call dot gear on it. Because it's a module, we're just able to call this method dot gear, or just this method gear. It's, send our hash that we've been sending before, and it'll act just as if we had an ordered list to send to this gear. So it's pretty interesting. It's pretty not complex. It's just there's a lot of unpacking to do just to understand some of those interesting points. So in this case, kind of went by pretty quickly. Gear is now part of some framework. This framework, we can't really change gear as the way we want it to. So that's why we make a wrapper, our interface, that we can use that in the Sandy Metz way. I don't know. I feel like I'm not, I almost like dogmatically saying that this is now the way to do it, but we have to be critical about it. So a few notes that she wants us to know. This is not a class. It's a Ruby module. And using a Ruby module lets us define separate and distinct objects that can accept the gear message, but without having to have an instance of the gear wrapper. So like I said, we're not setting a new gear wrapper. We're just sending a method call to gear wrapper, and it gives us an object of gear that we're used to the gear object that we're used to. And because it's a module, sorry.
Oh, go ahead.
Because it's a module, I'm familiar using modules in the sense where other classes would then use the module as well. In this case, that's not the case. I don't know if I can make that clear. And so if I have a module named home repairs, and I have a bathroom class and a kitchen class, and there's certain methods that I want to use from home repair, that's when I would use a module. I'm a little bit shaky on that. I would appreciate any clarification, but that's my understanding of the normal use of module. I'm not saying this is absolutely abnormal, but it's not meant to be used by another class. I'll just highlight that portion. It's just the idea of that module is to have something that responds to the gear message and that provides us a gear object.
Just pointing out, this is a utility module and not one that you use to augment, to mix in. It's not a mixin.
And yeah,
it's a utility module.
Cool.
Yeah, and then basic, she's just using it as a namespace.
Okay.
I think a lot of times, if I know it's not going to be a mix-in, I just go with classes.
Mhm.
When we go to namespace, it depends. I mean, and again, it's all what's the word I'm looking for? You're kind of like pre-hedging your bets on what you think are going to happen. Kind of like when Diego and I say, you know, we don't use structs because any program of any length ends up outgrowing the struct, so we don't even bother to do it in the refactor later. And that doesn't always happen, and maybe it's more unique to the way Diego and I code. So the way when I look at this one, I wouldn't have put in a module. If I'm just making a gear, I might have like a create gear that I refactor into a module later if it turns out I need it anywhere besides this class.
Mm-hmm.
And then I kind of like in my mind the clarity of what that method says. Create gear, pass a hash. Oh, what's it doing? It's creating a gear. This gear wrapper dot gear implies to me I'm getting a gear wrapper and not a gear. Like I'm getting some kind of proxy or decorator or some other class. When I say gear wrapper, I think I'm getting something different. So a method to me, and again, if you look at, and we should study that one maybe next, design patterns. There's a difference between a factory object and a factory method. This is technically a factory method, a method that creates objects. And at which point I go, well, then I'd be lazy and I just write a method, create gear, which is very clear what it does. The gear, and it doesn't create a gear wrapper. Gear wrapper dot gear doesn't necessarily say to me, I'm not getting a gear wrapper back.
Yeah, yeah.
So that's kind of how I would do it. Again, a lot of it is taste. A lot of it is hedging your bets. This one implies to me that Sandy thinks she's going to have other gear wrapper functions.
Okay, yeah. So instead of it being a factory method, she thinks that gear wrapper could become like a factory object.
Gear wrapper dot gear, and then gear wrapper dot double gear. I don't know. Maybe she's anticipating that. But you know, from when I look at the code right now, it's like, oh, you know, I would just do method create gear until I'm proved otherwise, and then it may be a module create gear, create double gear. At which point maybe I drop the creates, and that's almost like a coding convention thing where do you put verbs in the noun, I mean in the method and stuff like that.
Yeah, it's not straightforward, you know, that, and I appreciate you bringing that up. You know, it's like
a method that returns a noun, and somewhere in somebody's 101 is your objects are nouns and your methods are verbs. And that's sort of why I like the, you know, maybe I'm the old school of that create here tells me what it's doing, but adder accessor is an example in Ruby where you have a method that just returns an object. So, you know, taste and convention sort of push that.
All right. So we'll go on to the final section, managing dependency direction. A little bit vague, not, you know, it's not, you know, heavy with the examples like the previous section, but we're back to our code snippet. This time we have our, instead of gear calling out or depending on a wheel class, we now have something called dependency inversion, or is that right? The dependency, we're now reversing the dependency, sorry. We reversed the dependency, so now before we had gear depending on a wheel class, now we have wheel depending on a gear class. Personally, this is the subsection that got me a little bit confused because I didn't really gain any insight as to what was great about reversing the dependencies. All I got was just don't do it. And they're like, okay,
well,
fine.
She's saying that you may be working with a framework where it was the other way. So just in order to give an example and like open your eyes to how things could be different, she just reverses it.
Oh, okay.
And then it's showing that although it may not apply here, there may be an example in your code or a new code that you're about to write where you should at least consider it. When I read this, I didn't think it was better. Actually, it's probably worse, but I don't know. The chart below might help us.
Yeah.
I didn't even evaluate that.
It's so, yeah. If anyone else wants to expand on it later or whatever, but there there's the next set of criteria, in a sense, choosing dependency direction. There are 3 bullet points. Some classes are more likely than others to have changes in requirements. This is where I start thinking financial, like, because we're here, like volatility. You know, some things are more volatile than other things. And now we give names to it. We call, let's say, more volatile classes are known as concrete, and less volatile classes are known as abstract.
That's an OO thing. A concrete class, to use Java as the perfect example, you make an interface that describes what the methods are, and then you instantiate that specific as a concrete class. An abstract class is a class that gives you structure. These methods are called and possibly what data they carry. The concrete classes are specific instantiations, subclasses, or in Java, I forget what you do when you inherit from an interface. I forgot to name that one, but where you instantiate the concrete. So abstract is in general. In general, all round things have diameters. Well, wheel is a concrete version of a round thing. So it's not volatility. That's a specific to programming.
Okay, I'll abandon that then, because that's wrong. Sorry. So yeah, I guess abstract would mean things that we say, objects that we're familiar with and their properties, whereas concrete classes, given methods and class names, I guess.
No, it's like databases. Databases is the abstract class, but Oracle's a concrete one, and Postgres is a concrete version of database, which you can look at the abstract class and see what's common from these databases.
Okay, yeah, thank you. That makes it a lot clearer. Concrete classes, very specific example of what an abstract class could be, if it's the same type. And then, so overall, whether it's concrete or abstract, if it has many dependents, meaning that there's many objects that depend on that class, those objects could have potential to change. So the idea is, let's get some examples of understanding what changes. So something that really doesn't change in Ruby are Ruby-based classes. We have our string, we have array, we have a general idea of how they'll, and we have the multiplication operator. We have a general, expectation of how they'll behave, and we don't expect them to change. Framework classes, on the other hand, are more susceptible to change than our Ruby-based classes. Our framework classes, let's say Rails. Rails could change from one, version to another. Not a lot, not terribly so, but definitely a little bit more than Ruby-based classes does. And of course, our applications change much more frequently than the framework that we build upon. Just an idea of, what changes in how common, what's a normal expectation of change, something comparing between things that rarely change with things that are more likely to change.
Let's wrap up on this paragraph.
Sure.
If we got 3 minutes to go, and if we have any discussion, if we're going to end on time, we should start now.
Sure. I'll just end with avoiding dependent laden classes, which is this final section. And we see this chart. We see the A, B, C, D zones. And so here we have on the y-axis, the number of dependents, how many objects depend on the class. And then the likelihood of requirements to change, I think of it as between abstract and concrete. Concrete being, what we've just talked about, abstract being, let's say, the diameter of a wheel. And in it, she's defined something called the abstract zone, the danger zone, and 2 neutral zones. And that the majority of good programs or good applications should have classes that inhabit the A, B, and C squares, sort of the abstract zone and the neutral zones. Classes that are a real danger are those that inhabit the danger zone, that have too many objects that depend on it, and then being likely to change. And so many changes could then mean, much more time spent debugging. And with that, I can leave it at that, or we can expand on that.
No, we should.
You keep going down? Okay, I'll go down.
Well, we might start next session with that one. I think that picture is a little deeper than a 1.5 minute description of. Anyone else got any comments besides yapping me?
Yeah, I've got one. So if we go back up to the isolate vulnerable external messages. So this is the section where we're like kind of factoring out the wheel.diameter into a separate method.
Yeah.
That's kind of wanted to note here that this is probably like, first of all, a really great job. I think you did excellent with the presentation. The pacing was really, really good. And I like most of the things that this chapter covers, but this one seemed like a little weird to me. That you basically, when you're measuring method complexity, I think there's like a term called like cyclomatic complexity, and the number of references and method calls and things like that in the method determine how complex it is. And things like code climate will measure how complex each method is and suggest that you lower the complexity. And here is one of the cases where I think we're lowering the complexity by like 1 tick by not having a reference to wheel, right? But we're adding 3 lines of code. So I just kind of wanted to comment on, the amount of complexity you're saving in the gear inches method versus the extra code that's added. In this case, might not be worth. It's just interesting to think about that kind of thing, is how much you're saving, because a lot of these other things, you're pulling a great deal of complexity out of one method and adding a relatively complex other method to take the place, so that it's a little more even. But here it's just kind of one wrapper method.
Yeah, in the previous chapter, she had an example where I forget something got complicated. Instead of blank dot this, it was always blank dot this star some variable. So this would be sort of an example of pre-extracting that. Well, what if wheel diameter everywhere is now wheel diameter star error factor? In pulling it into diameter, you only change it 1 place. And the previous chapter with her constructor injection was, she had 2 groups. She had a constructor injection or a lazy method. And the beauty of that is wheel.new is only 1 place. You can easily see that diameter has a wheel.new and circumference has a wheel.new. You change wheel, you got to change 2 places. Her previous one, she moved the construction either to the constructor or the lazy thing. And in moving wheel diameter to here, she is anything that might call diameter. If you call this method, only have to change in 1 place. So that may be a preemptive move. What's the word? Premature.
Yes.
Optimization. And again, yes, maybe her experience is she always ends up doing this, so she does it up front.
Yeah, I agree. If it's more complex than just one reference, I totally agree. I just wanted to point out, I don't think this is like a good, do it all the time rule.
Yeah, I don't I have to think it over whether I would do this every time. I don't do this until I see more than a couple. But there's only 1 here. I don't think I would do it for 1.
There's
if I had 3 wheel dot diameter, I might think about, oh, if this is ever going to change, maybe I should extract this. But then I might do it at the time it happens instead of preemptively doing it.
Yeah, and also if you need to do this, and the thing you're implementing is this simple, just where it's calling the method on another object, you can also use, if you're using Rails or maybe even active support has it, a delegates method. I forgot the exact syntax, but basically it does the same thing as these 3 lines of code in 1 line, and has some flexibility. Yeah.
No, I think to the reverse, people who do this too much kind of annoy me. Where they literally, it's stuff like this. diameter is wheel.diameter. There's like 20 methods now. And so when I'm going through the code, I end up traversing like 9 times as many methods than they could if inline it was super clear. And yet it wasn't used at 9 different places. So,
Right.
So prematurely doing this and going through code that does that, literally you have like, oh, the guy took this conditional and made it a conditional blah, blah, blah. Well, what was wrong with if something?
So an example here would be like it does, like a ratio plus times wheel diameter, right? Like a wheel diameter, or let's imagine it was like a surface, right? The way when it annoys me is when that extraction into another method is, and I think I talked about it the first time we've done this, is not something that's usable. Meaning, radius times radius should not be its own method. So that's a square, and it has nothing to do with a wheel, right? If you were to do a surface, right? Yeah. And the same thing is, I don't want to go in like it's a gear inches and have a method that calls like an intermediary result, and then into the intermediate result into something else. Meaning, it's okay to have ratio times wheel the diameter, right? But sometimes I see like gear inches just calling out a method, or like the grouping is nonsensical. So like the gear inches is not 2 sub methods, but it's just 1 method, or like that has like it's split into 3 or more things, and the other one is like 2. You know, times X, right? And I think it's very hard. It's a very hard thing to judge, but you kind of need to make sure that when you do those extraction, they make sense. They make sense with what you're talking
here. Yeah. When I look at this one line at the top code, it's clear to me the diameter of what? Ratio times the wheel's diameter. If it's just ratio star diameter, well, which diameter of which object? I have a gear and I have a wheel. Is it the diameter of the gear? Is it the diameter of the wheel? So it's actually, and again, it's always hard to come up with a good example. But I'm just looking at it. Actually, that's replacing that with just diameter. It tells me less information. I have to go to another code.
And again, when you have like a lot of these cascading things, you know, a method into another method into another method, like, so you have to look at like 6 different methods to see this one thing. Chances are there's an object that needs to be extracted.
Yeah. Sometimes it's just the darn thing should just be done inline. Sometimes I think there's a zealousness to return. Look, it's just one method here, but to understand it, I have to go like 9 levels deep. So sometimes the 4 lines in line is better than 26 methods to make that one word in a bunch of places. So, okay, that's cool. If there's no other comments, we'll wrap it up here. I think next week, next session, Andrew will wrap up his last few pages. I think there's only a handful of pages, so we should take care of that pretty quickly. And who wants to do chapter 4?
I'll do it.
All right. Yeah, I look forward to that. Okay, well then, until we adjourn again, thank you for coming to Nested Loops. Enjoy your object-only day.
Thank you.
Thank you.
I'm going to go check out some wheel dot diameters. So. All right, thank you.
Thank you.